No.
Hello, Mr. Ryan. How are you today? Today we talk about Cartesian product. Okay.
Not Cartesian, it's Cartesian.
Oh, Cartesian. Okay. Product is
another
word of multiply, right? Multiplication. Okay.
It is Cartesian.
Okay. Can we focus on the thing here? Okay. So this is another word of multiplication. Multiply. So look, if I have a b.
That's why it's a bit warm.
Yeah. Okay.
It's like this.
This is a list of A is AB, and a list of B is, let's say, a list, okay, or tuple. And 2.
Hey, how come A?
3.
How come A got letters and B got numbers?
Yeah, in Python you can mix, okay. You can even mix and match, okay. So this square bracket means a list, yeah. The list means you can change it. It's mutable. But if you do it, if you do this, Eric, if you do this, parentheses, yeah.
Parentheses. That's in maths.
Parentheses. These are called tuple.
Or bracket.
Yeah, or tuple. A tuple. The difference between tuple and a list. This is list. Is that a tuple is immutable, means after it you can't change the elements. But here I can say B0.
School Island stupid.
Yeah, B0 equals, let's say, Eric. Okay.
It's just a long shot.
And then what happened?
B0.
What happened? Then you will replace this to Eric. Yeah, it's okay.
Aha! Not
yeah.
A or not 1 or 2. MySpace.
Can you focus? Look, if C equals this tuple, and if you say C0 equals that, it's not. You are not allowed to do that because it's tuple. You cannot change it, right? That's the difference between tuple and the list. Okay. So here, Cartesian product. Okay. Look, A Cartesian product B. In mathematics, yeah, B. What does it equal?
A times B.
Look, this is mathematics Cartesian. It's not the Python one, right? You can.
Is that times or something?
It's not. I mean, I'm just saying that in mathematics Cartesian, it's nothing to do with the Python, right? You cannot do a multiply in Python using this way. Cartesian product AB equals what? You take this. You will take each element of A and try the combination with each element of B. So what does it equal? You become equals that. A list?
Yeah.
No, a tuple. It will be a tuple. Tuple
of this one.
It will be A1 and then what?
Is that a dot or something?
No, a tuple, another tuple. And then A2, yeah? And then A3, you got it? And then B1, got it? B2 and B3.
3. I got it.
Okay, so what does it mean? Look, it's A1, A2, A3. This is Cartesian product. B1, P2, P3. All these are written in tuples, right? Does it make sense? So what? Can you tell me what's the Cartesian product?
Hello guys. Playtime. That's first search.
Not yet. You're not understanding. You're just guessing. Okay. So what's this?
Boom.
Does it make sense? Can you tell me?
Oh. Okay, so this is so this is tuple and this is list, but you just rub it out anyway. Tuple is immutable, I think, and this one is.
Tuple is immutable. A list is immutable. That's the difference.
Yeah.
And when you multiply these two Cartesian product, how do you multiply?
Okay. So you do A1, A2, A3. Then B1, B2, B3.
Exactly.
Yeah, I got it, baby.
Okay. So it's in Python we have this. You can do this. You have an iter tool, yeah, iterator tool. Dot product do this exactly. Okay. So you can do this. You can from iter tool import product and then we can use this product function. So you can say this, look, you can do this. A equals list, because this product returns a generator, you know, the year thing. It doesn't actually give you a list, but you need to convert it to a list or tuple, yeah? List, and then you can do this product, and you tell me what's the outcome, okay? Product, let's say 1, 2, and then another one, 3, 4, like that. So what's A? What does A become?
21.
What's A? A is a list, yeah?
Yeah, list of products 1.
Cartesian product of A, 1, 2. So A is what? Can you tell me?
A is.
Can you tell me?
Is a list.
A list of what?
24.
No. Cartesian product, I just told you. Remember that thing? You don't understand now?
The thing.
A tuple, yeah? It should be 1, 3. And what's next?
2, 4. Oh, 1, 4.
1, 4.
2, 3, 2, 4. Yeah, I got it.
Okay, yeah, got it. So look, it's this product of this. You will take each element of 1, 1, 3, 1, 4, and 2, 3, 2, 4. Yeah, easy to understand combination, right? And then you become each one is a tuple, and then it returns a list, a generator for this each tuple. You can convert it to a list. Okay, that's what it actually does.
Quick.
So if I want to implement this product, okay, is given 2 things, and you can change it to list to tuple. It doesn't matter. Yeah, it still gives this result. Okay, does it make sense? Remember the curly brace and not the curly brace, the bracket, the parenthesis and the square bracket. Okay.
Yeah.
Okay. Now we want
The
to.
last thing was 24.
You times it together, yeah? It's a factorial. Okay, so now look, let's define if this is a p function, alright? A, B, okay, 2 list or tuple. This could be tutor or list. And now,
Cut them.
okay, so how, look,
Yo,
we can do this.
forgot.
Look, for I
I got a chin rest.
in, if we want to go to the first element, which is A, and then second one,
Column.
for J in B.
Column.
And then yield. Remember this keyword?
Yield.
Okay, yield the tuple of what? Can you tell me? Yield the tuple of what?
Oh,
A is and then A is 1, 2. B is 3, 4. And I is for the element in the first in A. J is for the element in B. So yield the what? Come on, it's very obvious.
A
is the list.
I
And what?
J.
Yeah, exactly. That's it. That's for the product, okay? Product. Does it make sense? When you yield one, this is the tuple, yeah?
That
This
J looks weird.
okay,
It's
does
like
it make
this.
sense? What's the, if there are n elements in A, m elements in B, what's the time complexity?
N times N.
We're done, okay.
That's what I said.
Yeah, the yield thing.
Oh,
Remember this yield
Well,
thing? What's
I
yield
said-
thing? Can you tell me what's
Oh,
yield?
it's just like promise me.
Ryan's
like,
song.
Mummy said she's gonna give us £5 on Fridays.
Okay,
Which
and
is
then,
tomorrow.
Yeah, yeah, I
okay,
got
it's
it.
like a promise. When you ask for
Yeah,
it, then
that's
you will return.
exactly
Okay,
what I said.
okay.
Yeah, yeah.
Okay, and then what?
No, Robbie, now.
No, not yet, not yet, not yet.
Oh.
Not yet. I'm not finished yet.
Yeah.
Okay, quiet.
Okay.
So this product thing, Eric, actually iterable product can support more than 2 elements, yeah? Eric, look, you know what? You know this mean function, yeah? When you take mean function, 1,
You
2,
need to find.
no, this is mathematics, it's in Python already defined. Mean function, 1, 2, it returns what?
1.
Okay, and then you can look, you can say 1, 3, 4, 5. You can keep as many. It's a parameters. It's not a list. Yeah. So look at that 4 parameters. There are 2 parameters, and then this will still work, right? Gives 1. So the point is that the number of parameters. Yeah, we call it the number of parameters. It's not fixed. Remember in Python, if you want to define mean A, B.
Cut.
And you can say if A smaller than B, return what? A. Else return B, yeah?
Mm.
But here, look. it's already fixed 2. So how does this work? Because look, it's supposed more than 2, right? And 5, 6, etc. Then the thing is that you can use the variant argument. So you define as this mean, and then you put a star here. Star nums. Okay? And then how does it do? So you can say, okay, star means that these nums, you can give as many parameters as possible, right? It does not have to be 1, 2 fixed number. You can give 2, 3, 5, 100.
I'll give 0.
Yeah, it still works. Then how do you do it? Look, you can say answer. At the beginning, we give a very big number, yeah, infinity, right? And then look, for I in nums, I know how do I do with this answer thing, alright?
Yes.
Answer equals what? What? And then return answer. Can you tell me? We want to try to find the minimum of all the elements in nums. Okay, it's not there. Come on, you need to understand. Follow me.
Okay, so
I want to get a minimum. So what?
so equals minimum.
Okay, but not the minimum. Okay, let's define this as a f function. Okay, so this mean is the and then what? Mean what?
No.
What? I want to get the means of all numbers. So what?
Mean of nums.
Sorry?
Nums.
I is all the numbers in I and then what?
Nums.
Why is it nums? I want to get the answer. Come on.
Answer.
Eric, do you understand? Do you understand? And then return the answer, okay? Because the answer is the maximum at the beginning. And then we want to get the minimum, yeah? Keep updating with the minimum, right? Yeah? So the point here is we're using these to denote the variant number of the parameters. Got it? Okay, so the Cartesian product, coming back to this eta product, yeah? Eta 2 dot product. You can take as many parameters as you want. So remember we have these the 4 only it doesn't work, right? Remember the first iteration we have for I in A, for J in B, remember? Yeah, and yet IJ. This wouldn't work because you make it may contain more than 3 elements. Yeah, it could contain A, B, C. Okay, this only works for 2 elements. So how do you calculate a Cartesian product for 3 elements? Right, 1, 2, and then 3, 4, and then 5, 6. What's the Cartesian product? Can you guess? 1, 3, 5.
1, 3, 5.
1, 3, 6. 2,
3, 5. 2, 3, 6. 2, 4, 5. 2, 4, 6, 6, 6.
Wait. No.
6, 6.
No. 1 is 1, 3, 5, 1, 3, 6. Right?
Yeah.
1, 4, 5, 1, 4, 6. 2, 4, 3, 5, 2, 3, 6. 2, 4, 5, 2, 4, 6. Okay? Got it? Yeah? So how do we implement this product supporting the variance of the list ABCD, you know? How can we do this? If we're not supposing that, we can do this. For I in A, for J in B, and then for K in C, yeah? You can, if you are not already know there are 3, you can do this and then yield what?
I, J, K.
Yeah, well done. That's it. But we are not sure how many of them. So how can we do it? Define product. Look, this. What should I put here? A. But how many? We want to put a symbol here to denote that there could be many of them.
Oh, the star sign.
Star sign. The variant. Yeah? So you can pass as many as you want. Okay. And now. We want to define the depth first search, yeah? We're using this depth first search, remember? DFS. the beginning will be left, the left, and then the current. I show you what does it mean. Okay, so look, A will be you can convert A will be passing like a list, and you look if it's 1, 2, 3, 4, 5, 6, yeah. A actually can be treated like a list, and then here left is the which we start from the first one, right? When it reach the last one, we know we have the answer. So for each one, I can iterate the possibility of all the numbers here. You'll be 1, 2, right? All right? Does it make sense? Here, look. If left equal length A, if we are reaching the end, yeah, we do reaching the end, right? Remember, we talked about this kind of algorithm before, right? It's quite similar, yeah? For currents, if the left pointer array, if the left pointer reaching the end, and we have a current solution, so we can yield here, yeah? Yield, we converted this current to tuple. Tuple current, and then return. Okay? Now we are at a left array. So how many possibilities in the A left? Yeah? So we want to for I in A left, right? Alright? Does it make sense? Yeah. So look, this is 1, 2. Left is here. Yeah? Another 3, 4. Okay, Eric, look. Left is here, right? A left is this thing. And A left, I will be 1, will be 2. And then I need to do what? Yield from DFS. Look at this yield from. I want to yield from what? DFS and left plus 1. And current, if I choose I, and then there will be current plus I, right? And then here will be it. And then at the beginning, I will yield from DFS. The first one, first.
0.
And at the beginning, it will be an empty list, right? Does it make sense? Empty list. Is it easy to understand or is not? Yes, no, yeah.
There's lots of yields.
Yeah. Okay. So this is the DFS. The left thing is at the beginning is here, right? At the beginning, I start with the first element, right? First list, right? When it gets to the end, then I know I found a combination. Remember, which is current and then list. Make it a tuple, right? At this point, current is a list. I make it a tuple. Otherwise, I'm here, right? And how many possibilities for the current one? It could be 1 or could be 2, right?
Yeah.
So for I in A left, it will be this. And then I try to move it to next one because if it move it to next one, right? Then I move it to next one because I can try 1 or 2 here and then move it to next one. With the current plus I, right? If I choose the first one, yeah, we can have another define. This is the local function, right? Does it make sense? Here we choose the I for current element, and then we try to put the next one. Remember we talked about this combination, right? Combination thingy. Do you still remember? 3 apples picking 2 apples.
I think it's a C.
Yeah. How many ways of putting it, right? But it's the same thing. For this one, I can pick all the elements in the left. I. That's the current choice. Once I make sure the current choice, I go to the next one, right? And I recorded the current options, which is plus I. Got it? Yeah? No, this is a bit difficult, but that's okay. You understand, yeah? Does it make sense? Which bit you don't understand? What?
It's fine.
It's fine, yeah. Okay, how about? Can you write Cartesian product with the 3 elements. Fixed. Easy.
Huh?
Define
Need to write one.
product. Okay. Product. A, B, C. Okay. So can you write a Cartesian product?
If there's 3 elements.
Yeah, 3 elements. So it's easy. Yeah.
Okay. So for I in.
For what?
I mean for.
For.
For I in A.
Yeah.
Yeah.
Hello.
For J.
In B.
B. For.
You need to have an indent. Okay. You can't write it at the same. Okay. Does it make sense?
C.
Oh yeah.
No, I mean for K if you say in.
You can. Yeah. Okay. And then what?
And then.
You want to.
Yield.
Yeah.
Yield IJK. Yield
Yeah.
IJK. What does it mean yield?
I promise I will give you this, but not yet until you want it. Okay.
Until I want
Okay.
IJ. What? Yay!
This is the. What's this? What does it mean? What's this here?
Tuple.
Tuple. If I can make it as this one, that will be what?
List.
What will be the list? Okay, got it. Okay, well, what's the time complexity if they are A here, B here, C elements here?
A, B, C.
A times B times C. Yeah, because look, one A. You're writing it too close to each other. You should be writing here for I, and then for J here, yeah, and for K here, yeah. You need to have a space, yeah. That means that this one belongs to this, right? If you write it here, it means that. Does it make sense, Eric?
Yeah.
Okay. Please don't do it, okay? Please.
No. Bye.